Hi guys, welcome to the next section, Data Mining and SQL Queries. In this section, we'll start with using Spark to analyze data. Next, we will see Spark Session and SQL. After that, we will look at combining data sets and loading JSON into Spark. Now, we move on to the first video of this section that deals with using Spark to analyze data. In this video, we're going to take a look at using Spark to analyze data. We will also see MapReduce example. The first thing to do in order to access Spark is to create a Spark context. The Spark context initializes all of Spark and sets up any access that may be needed to Hadoop if you're using that as well. Let's create a Spark context. Before creating, we need to upload a source file. Now, we will need to start a new Python notebook and rename it as using Spark to analyze data. We will add this code from the code bundle. Let's understand the code. First, we have imported SparkContext library. Next, we are setting a global variable for SparkContext if it is not created. After that, we read the Spark total line length file using this line of code. We use a Hadoop map function to split up the text file into different lines. After that, we use a Hadoop reduce function to calculate the length of all the lines and gather the lengths. Let's print the total length. As you can see, total length is 1065. We can use MapReduce in another example where we get the word counts from a file. A standard problem, but we use MapReduce to do most of the heavy lifting. Before creating, we need to upload a source file. Let's look at the code for this example. Open a new Python notebook and name it as another MapReduce example. We will add the code from the code bundle. First, we have imported PySpark. If the Spark context is not sent globally, we have set a variable for that. After that, we read the Spark file words. We will use the flatMap, map and reduce by key function. Now, let's print the results. Here is our output. It is assumed to be massive and the contents distributed over many handlers. Once the file is loaded, we split each line into words and then use a lambda function to tick off each occurrence of a word. The code is truly creating a new record for each word occurrence, such as at appears 1. For example, if the word at appears twice, each occurrence would have a record added like at appears 1. The idea is not to aggregate results yet, just record the appearances that we see. The idea is that the process could be split over multiple processors, where each processor generates these low-level information bits. We are not concerned with optimizing this process at all. Once we have all of these records, we summarize the record set according to the word occurrences mentioned. The counts object is also RDD in Spark. The last for loop runs a collect function against the RDD. As mentioned, this RDD could be distributed among many nodes. The collect function pulls in all copies of the RDD into one location. Then, we loop through each record. When we run this in Jupyter, we see something akin to this display. In this video, we've looked at using Spark to analyze data.